So, Rich is going to present graphics on his Silicon Graphics computer, and then we will compare them to Amiga graphics.
Nice.
And he'll tell other things about his computer also.
All right.
Other bits and trivia, stuff like that. So
Good
pull up a seat,
afternoon.
relax.
Commodore Los Angeles Super Show. My name is Richard Goedeken. I'm giving a presentation called 3D Graphics Pioneers. And so I'm going to be telling three long stories. The first story is about how 3D graphics rendering went through this big inflection point in the 90s where it went from impossibly expensive to mainstream and cheap, and how this caused this proliferation of hardware and software that was able to do for the first time 3D graphics. And the second story, I'm going to be talking about the Silicon Graphics Octane computer, which actually is under here. It's this green box under the table. The computer in general and that particular computer specifically. And then the third story is about the software that I'm going to be showing during class. And so if you guys think back to 1985, there was a music video by a classic rock group called Dire Straits. Money for Nothing was the music video, and when it came out, it blew everybody's mind because like you were seeing this really cool thing. It was like you were looking at the future of technology, of computers. Like it was rendered and it was 3D and it looked like these little people, you know, moving TVs and microwaves and stuff around. And so the hardware that they used to do that video production was a system that I'd never heard of. It's called a Bosch FGS 4000 CGI system. It took up half a rack, right? So, you know, it's like the size of half a refrigerator, and it cost $500,000.
Oh.
And they sold, that company Bosch sold about 150 of those around the world. And actually the FGS 4000 had a 68K processor, same as the Amiga, and all the rendering, all the pixel processing was custom boards. And so another early 3D thing was an arcade game. I think maybe Steve has this, iRobot.
Yeah.
And so that was an arcade game. It didn't sell very well because people didn't know how to play it, and they thought this thing is like, it looks cool, but it's not really that much fun. But so that I knew that it had 6809 CPUs, same as the Coco, and I thought graphics was rendered on the 6809. But as it turns out, that iRobot game had custom boards in it. What were they? They used 4 AMD 2901 4-bit slice programmable ALU chips, and it could do about 2,000 polygons per second. And so, and actually another little fun fact, that iRobot game in 1984 was one of the last two arcade games that Atari made as in its original incarnation before Atari split into Atari Games, which was the arcade unit, and Atari Corporation, which was sold to Tremere. And so then in the home computer and the PC worlds, 3D graphics in the late 80s and the early 90s were all software rendered. So like our favorite computer, the Amiga, had Stunt Car Racer, right? And that looks really cool, and that's all 3D rendered, but it was all done in software. Everything was rendered in flat shaded 3D polygons. So then in the PC world, you had Wolfenstein coming out in 1992 for DOS. That had texture mapped floors and walls. And then Doom was released December 1993 and became the fastest selling video game of all time. By 1995, there were more PCs with Doom installed than Windows 95. So this is beginning the acceleration of this massive trend that happened with 3D graphics. In 1996, Quake was released and took it even further to the next level. And so up until this time, 96, there were standalone 3D graphics accelerators that began to enter the PC market. Before that, there were only display adapters, right? You had your VGA, Super VGA, XGA, and all they did was have frame buffers that generated a video signal that went out to a monitor. And so, like, first it was all PAL-LED, 8-bit color, and then you had high color, true color, 16-bit, 24-bit color, but then starting in about 96, they started making 3D accelerators that would not just have a frame buffer that put pixels onto a monitor, but actually had processors on the video card to do 3D rendering. So one such early video card was the Diamond Edge 3D, which is based on the NVIDIA NV1 chip, which was released in November 1995. That was kind of unique because it could do actually 2D and 3D in the same card. Another big one that really opened up the market on the PC side was the Monster 3D, which used the 3DFX Voodoo chip. So the 3DFX Voodoo chip couldn't do 2D. It didn't have a frame buffer. It could only do 3D, and so you had to have a pass-through and have another video card that was your main video card, and then that 3D card, the Voodoo, was just for the 3D graphics. And so when I was in college, at this time in the late 90s, and I was very interested in writing software to do 3D graphics, and 1997-98 I wrote a 3D engine using MMX assembly language for DOS, and later made a screensaver and a demo out of it. So I had a friend back then who was heavily into first-person shooter games, Quake, and he was super excited about the upcoming OpenGL API, 3D graphics API, and the availability of GL Quake to take advantage of this new 3D hardware that was becoming available. Now, myself, being a programmer, I didn't really have any great expectations for the new hardware because I was more interested in writing my own 3D rendering software. Like, why do I want to outsource the programming to somebody else and use it on this GPU? And so I thought, oh, this isn't a big deal. I don't care about that. And so I definitely ended up being wrong about that. I didn't realize that 3D graphics GPUs going to usher in a completely new high-performance data processing architecture which would eventually give way to fully programmable, massively parallel processors. And that's what happened. And so the early 3D accelerators were completely fixed function. They could only be controlled through a graphics API like OpenGL, Glide, or Direct3D. But by the mid to late 2000s, fully general-purpose APIs became available, such as CUDA, OpenCL, and Metal, and these are still being used today. So another interesting thing about the early graphics cards is if you look at the performance metrics, the metrics that people talk about now for GPUs are the same sort of general computing metrics that we would use for any computer, right? You talk about memory, bandwidth, and you talk about how many flops, how many floating point operations can you do at a time, right? So the modern cards can do 10 teraflops, 20 teraflops, like they're insane, right? And even the first gen, like general purpose cards, could do a few gigaflops, right? Well, in the early days, before they were general purpose, nobody talked about megaflops and memory bandwidth. You talked about triangle performance, right? How many triangles can you do? What's your geometry performance? How many million triangles can you do per second? And then fill rate. How many pixels can you push per second? And so, and there were all these little details, right? Like, are you doing Goudard shading? Are you doing flat shading? Are you doing Phong shading? Are you doing texture mapping? And so all these different graphics cards would have different abilities based upon their hardware. And so this sort of explains how SGI fit in with the PC hardware that was available at the time. And so this SGI Octane, its original, the first generation graphics boards that they shipped with it were called Impact. And they had different levels. They had strong impact, high impact, and maximum impact. It came out in 1995. It could do 1 to 2.2 million triangles per second, and it could render 240 million Goudard shaded pixels per second, or 140 million textured pixels per second. Now compare that to the Riva TNT2. So one of the first graphics cards that I bought in the PC world was a Riva TNT2. So that was their 5th generation chip. That was the NV5. Came out 4 years later, 1999. It could do 9 million triangles per second in terms of geometry, and it could do 250 to 300 million textured pixels per second. So that was state of the art then. Now SGI came out with their next generation graphics hardware a year later, and so that the architecture is called Odyssey. The cards were called vPro, and so this machine has a V10 in it. The vPro hardware could do about 18 million triangles per second, and it could render, it could do texturing 450 million textured pixels per second. So it was a lot faster, it was a lot more performant, but I mean, if you look at the ratio, it's maybe twice as performant as that TNT2, but it didn't cost twice as much. It probably cost 20 times as much. Like, their hardware was extremely expensive. And so another thing, I started getting into 3D graphics in the late 1990s. I was very interested in stereoscopic 3D rendering. This is sort of a long aside. And so there was a place in Chicago called North Pier Mall on the Navy Pier on the lake. And it was a big mall, just your typical mall, but they also had a couple of interesting entertainment businesses there. One of them was a place where you could play a 3D game, and I can't remember the name of it, but like, you stood in this circle and you put on the headset and it was 3D, and you had like a handgun sort of thing, and it was networked, right? So there was like 4 or 6 stations, and you could play with your friends, and it was like, you know, 20 bucks a game or whatever. And it was terrible. Like, the experience was bad. It was 10, maybe 15 frames per second. It was, you know, it was just flat shaded. It, you know, it was super slow to respond to your movement. But I mean, they made a business out of it. It was like, there was no other game in town that was better than that when they started up. And they also, right next to that place, they had a place called the Battletech Center. I don't know if they ever had a Battletech Center like out here in California, but for us, like, I grew up in Iowa, that was a major thing. Like, we could go to Chicago, 3.5-hour drive, and go, you know, down to the lake and see this Battletech Center, and that stuff was amazing. So they opened the first Battletech Center in 1990 at the North Pier Mall, and then they opened one in Yokohama in 1992 and Tokyo in 93. Eventually, this company had 26 of these around the world, and they had some other games as well. Like, the first game that they had was Battletech, which was based on a role-playing game. And in Battletech, you have this, you know, you got a big mech. It's like a giant robot, and it's got all these abilities. It's got certain speed, and it's got a certain amount of power that it can generate, and certain types of weapons, and you would go around and just basically try to kill your friends. And so it's sort of a deathmatch type of a game. And so the Battletech game that they made, that they played at the Battletech Center, was based on that. It was all 3D rendered, and they sort of moved you through in a pipeline where you would go, you'd sign up, you'd get a time and wait for your time. So then when your time came, you go through a briefing, they explain how to use the hardware and whatnot, and then once that's over, everybody shuffles in, and they've got a bunch of pods, right? So maybe there's 8 pods, they're all networked together. You go there, you sit in, and it encloses you. They close the door. It's got a monitor, or it's got multiple monitors, like switches all over the place. It's got like a throttle control and a flight stick, and so then it comes up, and you're in the world, and you're driving your mech around, you know, trying to shoot your friends and whatnot. And so that was the experience of Battletech. And they also had another game called Red Planet, and I'll talk about that a little bit more in a second. But anyway, so they went through multiple generations of their hardware in the Battletech Center. So they created their second generation of hardware in 1991, and that actually used a CPU board based on the TMS 34010, which was the processor used for some of the 3D Atari arcade games. And yeah, so that TMS 34010 actually did the rendering. And that second generation hardware had a Commodore Amiga 500 for the secondary screen. I guess there was like a status display screen. Oh, right, and then after your game, so your game lasts 10 or 15 minutes, whatever, and maybe you die and somebody else dies and you restart, and you play through the game, and at the end you all walk out, and they've got another monitor that shows like a time lapse of the whole game, and you can see, oh, that's when I shot Steve, or that's when I fell over and my mech blew up. And it has like, they would give you a printout and say, your score is this, and everybody else's scores are these, and here's all the events that happened during your game. So you'd sort of have this like little keepsake to take home. And so that second gen hardware, they were trying to get it to maintain a higher frame rate and be able to network 8 players together and have all of them actually be able to run at a decent frame rate. So I think on that System 2 hardware, they were getting like 20 to 25 frames per second. And so, let's see, they redesigned it again for the System 3 hardware. They upgraded to the TMS 34020 CPU, and they actually went from having a bunch of separate cards to like a PC type system. And then, yeah, and then for their 4th generation hardware, which they nicknamed Tesla, that came out in late 1994, and they switched to PCs for that. They actually had 2 EISA slots for the video 3D hardware, 2 EISA Creative Sound Blaster Pro cards for the sound. It had 12 speakers, 3D sound, and it was originally a Pentium 90, and later they upgraded it to a Pentium Pro 200. And so that's probably the hardware that I saw when my friends and I would take road trips from college to go to Chicago. It was like their Gen 3 and their Gen 4 hardware. And they also had the server was a Macintosh PowerPC that was running the network, and the cockpits were running Novell DOS 7 to handle the networking. So, yeah, that was interesting stuff. I remember going there years later, and they were gone. And so, yeah, they didn't last probably too much beyond that, because the hardware became available to anybody. And like, why are you going to go pay $20 when you can just sit at your PC and shoot your friends from the comfort of your own office chair? The other thing that I really loved was 3D stereo vision. So the first 3D shutter glasses that I bought were called New Vision 3D Specs, and I think they were around 1996. They were connected with a wire to a parallel port. And then later I bought an ELSA Revelator 3D card, which was that TNT2, and the ELSA 3D glasses. And so these guys are shutter glasses, and they're infrared, so they're wireless. You don't have the wire, so that's a little bit nicer, and you have this little infrared emitter that transmits the signal. And so, let's see. Yeah. So, shutter glasses, the way these things work is they're just LCDs, and they can either be transparent or they can be opaque. And when it turns on and the system is running, the system synchronizes the glasses with the monitor, and it'll cover up one eye, say it'll cover up the right eye, turn it opaque, and draw the frame for the left eye. Then it switches. It makes the left eye opaque, and it draws the frame for the right eye. So you can essentially render 2 different frames from 2 different perspectives, and then deliver each of them to each of your eyes, and you get everything like pops out of the monitor. Everything becomes 3-dimensional. So that's the 3D shutter glasses. Another company which was at the forefront of this 3D graphics revolution was Silicon Graphics. So based in Mountain View, Google actually has taken over the campus where Silicon Graphics used to be, and now they're Google in those buildings. They developed some of the most high-performance and most widely used early professional 3D workstations. They were also one of the primary developers of the OpenGL 3D graphics API. So if you use OpenGL, there's a lot of numeric constants that still have SGI in their name. A lot of work was done, probably people know this, a lot of work was done on movies using those SGI machines. Jurassic Park in 1993 and the Super Nintendo Donkey Kong Country game were rendered on SGI Challenge machines, which SGI sort of had their workstation line and their mini computer line. So their workstations were Indy, Indigo, Indigo 2, Octane, Fuel, and Tesro. And their mini computers, they're like the size of a dorm fridge. They're big. They had Challenge, Challenge 2, and then I think they had some others as well. So that sort of covers like how 3D graphics first began in its infancy. Now I want to talk a little bit more about the Octane. So one of my buddies actually gave me my first Octane in August. And a lot of these machines were used in large capital equipment like MRIs, CAT scans in the medical field. The Octane that Dave gave me was used by one of his former colleagues who was a PhD medical researcher in the City of Hope. And so they used it for visualizing organic molecules. They had software that would allow them to like describe the three-dimensional physical layout of a molecule and be able to model it and look at it and render it. And so that's what they use those things for. When Dave gave me the Octane, it didn't work, and he gave it to me with the request that if I got it working again, he would like me to retrieve all the data off of the hard drive for his friend, the medical researcher, and give him the data that was on there because they couldn't get it because it was dead. And so I first suspected the power supply. It wouldn't turn on. The Octane actually was sold with two different power supplies. The one that was in the one that he gave me was called the Lucent power supply, and it was 623 watts. The bigger one was the Cherokee power supply, that was 747 watts. And those things, they're big. It's got a square section like that, and it's the entire depth of the computer. So it's about that deep, and they're probably 15 or 20 pounds, most of which is just heat sinks. So it's got 3 or 4 circuit boards in there that are all sort of like Tetris together, like a maze. And so I pulled that apart, and I found there was a forum posting by somebody who had gone through one of those things that wasn't working, and they called it the click of death. It was the same symptom that everybody had. And he had recapped it, still didn't work. He noticed when he tried to power it on, it made this whining noise, and so he narrowed it down to the location on one of the circuit boards where that whining was coming from, and he replaced a few components, and it fixed it. And so I looked at that, and I thought, okay, I bet it's probably this one particular component. So I ordered that. They made an upgraded version that's still available from Mouser, and it's a little 3-pin TO220 chip, and what it does is it provides 5 volts all the time. Like, the computer doesn't have to be turned on, power supply doesn't have to be turned on, it still provides 5 volts. And so it runs the startup circuit that allows it to, bring up the whole power supply when you push the button. And so I recapped it, and it sat on my workbench for about 4 months because it was a daunting task. And I knew, like, it's going to be a lot of work and it's kind of a pain in the ass, but I knew, okay, I just got to get through it. And sort of after a couple of months, I picked up the pace and got it going. And I recapped it, put that new chip in it, that new little power component, put it all back together, stuck it in the Octane, turned it on, and it powered up. Like, I was super excited. It was like 2 days before I was taking a road trip driving back to Iowa for Christmas, and so I was super excited because I'd been concerned about this for months and really wanted to get it working and wasn't sure if it was going to work or not, but I got it working. And so I had also, so it has a SCSI drive in it, right? It's the drives just slot into a backplane, and it's got this 80-pin SCA connector, which is a standard, and it gives both power and data all in a single connector. And so before I had even gotten the Octane working, I intended to just hook it up to my PC running Linux, see if I can get the data off it. And so I ordered an SCA adapter from eBay, which goes into that SCA 80-pin connector. Then on the back side, it's got a Molex 4-pin for power, and it's got a 50-pin SCSI that you can then connect to your SCSI host bus adapter. So I got a PCI Express host bus adapter for my Linux machine, got the drivers for that, got everything working, and like nothing happened. Turn on the computer, like it wouldn't see the drive at all. And I tried a bunch of different stuff, and every now and then like the drive wouldn't even spin up and the card wouldn't see it. And so I ended up buying another of those SCA adapters off of eBay, and that one worked. And so the first one was dead. I guess they just make these things so cheap. It's passive, like there's no active components on it at all. They're just made so poorly, and they don't even test them, and so it didn't even work. But I got that second one, and so I imaged the drive. I got the block image off of it on my Linux machine. I installed the Linux kernel drivers for the XFS file system. So that's another incredible contribution that SGI made to the computing industry, is they invented the XFS file system, which is still used in high-performance computing to this day. And so Linux has support for it. I tried to read the image, would not read it. I guess the drivers, the software that's in the Linux driver for the XFS file system doesn't support the older versions of XFS, which are what are actually used under iRigs on the original SGI machines. And so, anyways, let's see. So yeah, I had just a couple of days with the Octane before I left for a couple of weeks for Christmas. I played with it a little bit, I booted it up, I could log into the OS and it was working. And so when I was driving to Iowa, I was like really excited about this machine. I really wanted to do something with it. And I was thinking like, what could I do? What could I show off at class that would be awesome with this machine, that would be an awesome demo? So while I was driving through Nebraska, I like came up with the greatest idea. Like, this is going to be so cool. Like, I know if I can pull this off, man, this is going to totally rock. But I knew I would need to upgrade the machine. So the Octane that Dave gave me, it originally come with the base model graphics card, and I knew it wasn't going to be fast enough. And so when I was in Iowa, I ordered a bunch of stuff. I spent way too much money. So I ordered the top of the line Impact, which was called the MXE, and then I also, so that one I thought would work with the Octane just as it was. Now the V Pro, I really wanted the V Pro because these things are like 3 times faster, but they require the bigger power supply. They require that 747 watt Cherokee power supply, and they require the newest version of the front plane. So on the Octane, the front plane is this board that sits up and down in the very front of the case, and everything behind like plugs into it. And so it's got this chip called the Crossbow. And the Crossbow, it's basically like a PCI Express controller. Instead of having a bus like every other computer does here, where the bandwidth is shared between multiple devices, with that Crossbow, it's like a modern PC where you've got dedicated lanes, and every card has its own lanes that talk directly to any other device. And so that's exactly how it works in the Octane, where that Crossbow chip essentially routes the traffic between any 2 devices. But in order to use that V Pro card, you need to have the newest version of that, and I didn't know which version this computer had. And so I knew that I needed a power supply, maybe I needed a front plane board, and so to get a V Pro, so I found a V Pro from Taiwan, okay, and they shipped it to me from Taiwan, and I found a power supply, the Cherokee power supply, and those things, if they're working, they go for like $300 on eBay. And so I found one that was as is, untested, maybe working for like $100, and so okay, fine, ship it to me. So I come home from Christmas, I got the Cherokee, I got the MXE card, and I got the V Pro, which I couldn't use at that time. And so I got home, plugged in the Cherokee power supply, and it worked, right? So that was a win. So I didn't have to do anything. I figured if it doesn't work, I already fixed one of them, I can probably fix another one. I installed the MXE graphics board, and that worked also. So Super Tux Racer. So another interesting thing about the SGI hardware, this is the SI card that was originally in the Octane that Dave gave me. And it's, I mean, this thing is heavy. It occupies 1/4 of the board, right? And you can put other boards here as well. But this thing does not have texture memory on it. It can only do flat shading. Now, there's an expansion area here where you can put a texture RAM board on here and it will do texturing. If you do not have that texture board, which this SI does not, then if you run OpenGL software that does texturing, it is horribly slow. It is fucking ridiculously slow. It somehow renders it on the CPU and then pushes it up over the bus. And so the iRigs, right, the operating system on this guy is Unix. You can install GCC, you can install all the Unix tools. I installed Super Tux Racer, and on that Octane with that SI graphics board, it took about 15 seconds to render a single frame. Okay, so the MXE, the upgraded MXE graphics that I got is like twice as big, right? It takes up this entire thing. And it also is fully populated with texture memory. And so once I installed that MXE board, it went from 15 seconds per frame for Tux Racer to about 30 FPS. and it was playable. It was great. I was like, okay, this is cool. So then I put my software on there, and it took me just a few days to get my software to the place where it would actually run. And mostly it's because of Indian problems, right? That my software had been written for the PC x86, which is little Indian. The MIPS processor in the SGI machines is big Indian, and so sometimes stuff needs to be rewritten a little bit. And so I got it working, but with that MXC graphics board, it wasn't quite fast enough. It was about 10 or 15% slower than the level of performance that I needed it to be in order to do what I wanted it to do. And so so that meant I had to somehow get the vPro working. I've spent quite a bit of time getting the operating system set up and the software set up. The machine has a built-in 100 megabit Ethernet port. You can run modern tools like SSH, SCP, Git, GCC. And so if you can find binaries or if you can build the software from source. So the original software installation method on the SGI machines was all done with CD. And it's kind of interesting. They had a pretty decent software package manager. It's clunky in terms of modern aesthetics, but for 1995, I think it worked pretty well. It was centralized. It knew everything that you had installed. It understood dependencies, and so if you needed to install a particular package and it required other libraries, it would go out and find those libraries or tell you you need to install these as well. And so it worked pretty nicely, but it was all done with CD. And so I did actually buy some SCSI CD-ROM drives off of eBay, but I never ended up using them because it's also possible to do network software installation with this, and it was really clunky up until about a year ago, because you'd have to have another Unix machine like a Linux box, and you'd have to install 3 separate servers. It required a boot P server, an SFTP server, and something else, and all of this configuration and this thing pointing here and that thing pointing there. And it was kind of a pain. Well, somebody wrote a tool called Love about a year ago, and it's just a single script, and you can just get a configuration file that points to your installation CDs. You can have a bunch of them and just run this single script, and boom, it's working. And then on the SGI machine, you'll go into the software tool and you'll just use URLs, and it'll just get everything over the network, and that works great. And so that's what I did. I installed fresh IRIX 6.5.30, which is the last version of IRIX that SGI had ever released. Installed all the tools. It was a pain to get Git working. That was because Git requires curl, and curl requires OpenSSL, and both of those are huge. And so getting that stuff built was a pain. It took me about a week, but finally I got it working. And so once I got all this stuff working and I started using the machine and installing the software, I just fell in love with the machine. It's like a bridge between a retro and modern. It's an old machine, but it's got all these new tools that you can use, and it's Unix, which I love Unix, and it's fast and it's pretty. And Dave had also given me this awesome 20-inch CRT, and so I think it's just like the bee's knees. So after I was happy with the setup of the operating system and the software environment, I started working on my own software to show here at class. And so SGI actually had their own home-built compiler that they shipped that was expensive, that you had to license, called MIPS Pro. And it supports C99 and C++03, so it's relatively modern stuff. You can build a lot of software packages with that. And then there's a community of SGI users and enthusiasts, and they also have a bunch of software that they've built. You can get newer GCC builds that will run. But I wanted to use MIPS Pro for mine, and so I was able to get my software running on Octane pretty quickly after dealing with the big Indian bugs, just a few of them. But then, like I said, with MXC Graphics, it wasn't quite fast enough. So I briefly considered, because this actually, for the Octane, this isn't the Octane that Dave gave me, but the Octane that Dave gave me had a dual processor CPU card in it, which was a really unique thing of the Octane, because previous to the Octane, all of their systems were uniprocessor. So the Octane had the option of having a dual processor. You could have R10K, R12K, or R14K CPUs from about 175 megahertz all the way up to 600 megahertz. And so I had thought maybe I can do some crazy multi-threaded OpenGL stuff and reach my performance target, but I kind of thought the chance of success of doing that was low and that it would be unnecessarily complicated. So I decided, okay, I need to get the vPro. So I ran the little software tool here to determine which version of that front plane board I had, and I had the old one. So I needed to get a new front plane board. So I started looking around for a front plane board. There's a when I went to VCF SoCal in February, there was IRIX SGI guys there, and they told me, okay, well, you need to get in touch with this guy, Doug Mashik, who's out like on the East Coast. And I had seen his website. He's got tons of parts. Like, he's got all these SGI parts. There's two guys, one Ian and Doug, that have two different sales businesses that are still selling old parts. And so I thought maybe I knew I could get it from him. I saw it on his website, but I thought it's a little bit expensive. So when I talked to the guys at VCF, they said, well, if you really want SGI hardware, you either come to VCF and go to the consignment, or you can talk to Doug. And so I thought, I don't know if I want to spend as much as he's asking for that front plane board. And so I posted on a couple of SGI forums, and I almost got scammed. Like, somebody responded to me, and he was a scammer, and he said, yeah, I've got one. How much do you want for it, and all this stuff. And we went back and forth, and I was one click away from sending my money to this like Indian or Nigerian scammer. The thing that tipped me off, and it wasn't the PayPal page that said, this may be a scam. Like, that didn't tip me off. It was the fact that they were asking an extra $5, because he asked me to send it friends and family, so I was going to send it friends and family. And like, there shouldn't be a charge. Like, why is there a charge? When did they start charging $5 extra for friends and family? Like, but they did, right? They were forcing me to pay this extra $5, and eventually I figured out they force that extra $5 charge when it's going to a foreign account. And so this guy's not actually in Kansas. He's probably in India. And so, yeah, I was like, dude, you got to stop scamming, man. So then after that, I bit the bullet. I bought the board from Mashik, and he sent it to me, and that was, there's a ton of them that were for sale on eBay, but they were all the old version. They were all the 1.3 crossbow chips, and I needed the 1.4 crossbow chip. So then, okay, so I got the extra board, and I'm thinking, I've got an extra Cherokee power supply, I've got this extra vPro graphics card, I've got the front plane, and I've got a couple of hard drives. I can make an entirely new Octane if I just get another case and CPU board. And so then, and I kind of thought, well, I'd like to get a faster CPU board anyways. It'd be nice to have like 400 megahertz or 600 megahertz. And so I thought, well, I might as well just get an extra case. And so I started hanging out on the Discord server for SGI, and there's a guy there who sells a lot of parts, and he kind of put together a deal, and it turned out that I need more than just a case and a CPU board. You also need drive cage, a SCSI backplane, a fan, and all these other little parts. And so he kind of put together this deal, and it was okay, but it was not too great. And I was just about to send him money to pay for it. And I got a special offer from an eBay seller that had a listing for a complete Octane system, and I'd been watching his listing. And so he sent me a special offer, and I was like, hey, that's actually a pretty good deal. It was a decently fast CPU, it was an upgrade. It was a dual R12K, 270 megahertz, and the machine was working. It had a Cherokee power supply, and he had offered me $100 off. And so I sent him a counter offer, $150 off, and he accepted. So I'm like, okay, great, I'm getting another Octane. So I get my second Octane, this was like maybe 6 weeks ago, in this giant box in the mail. And this computer is like 50 pounds, right? They're so heavy. And he had packed it okay, but not like fabulous. And so I have to pull it out to show you, but the power supply, the way it's like this big sort of rectangle thing, and it slots into the back. It's got this handle on the back, and it slots in and just locks in place. And so you can take it and just pull it out by the handle. And so when I pulled out the Octane, it was like on its back in the box. And it was inside of a box, and he had taken this really hard foam and cut out slots for the handles and fit it right up against the back, and so it was nice and flat. And then that was inside of a box, and then there was bubble wrap under that, and it was sitting down. And so when I pulled it out, that handle that was on the power supply is the farthest, it's the backmost thing in the whole computer. Well, it was broken off. And so I thought, oh, that's kind of a bummer. And so I thought, okay, well, it's supposed to be working, right? He had pictures in the listing of the machine working, so I know the machine should work. I plug it in, you hear this little zap, like, okay. It didn't alarm me too much, because some things, they do spark when you plug them in, right? It's like an inrush current to charge capacitors or whatever, it'll just, but I heard that zap, and I'm like, push the power button, nothing happened. Like, oh, that's too bad. And so then I thought, oh, but wait, I already have an extra Cherokee power supply, right? And so I pulled that power supply out, which actually turns out is extremely difficult without the handle. Plugged in the Cherokee that I had, powered it up, and everything was working. So then I went back to the original seller and I said, oh, the power supply kind of broke in the shipping. Can you like give me another $100 or whatever? And so he did. So I got another $100 off. So that was an even better deal. And so now I had all the parts, right? I had the V Pro, I had the new Octane, and I had the front plane, and I just needed to put them together. So another daunting task. I procrastinated a week or two, and then this brings up another story. So when I lived in Dallas, I had a good friend who was a mechanic, and he once told me that the way that you replace a clutch in a BMW motorcycle is that you start by taking off the rear tail light, and then you disassemble things on the bike, working your way forward, including the motor, until you get to the clutch at the very front. And then you replace it, and then you do everything in reverse. So replacing the front plane on this computer is much like that. You take every single thing apart, and once you get to the very end, you have the front plane board. But still, I would say it's easier than replacing the accelerator board in an Amiga 3000. So the build quality of the Octane is amazing. I've never worked on a machine like this before. Like all the consumer stuff that I've repaired, upgraded, Commodore, the Amiga, the Tandy, the Atari, it was all designed and built with a strong focus on cost reduction because it was made for the mass market, right? They want to sell as many as they possibly could. But with SGI, it was cost is no object. They can, spend however much they want. And so it was really, the machine is really over-engineered, but in a good way. Like there's no cables. Inside this entire computer, there's no cables at all. Everything just slots together and clicks. And they have these crazy connectors, which are really pretty fragile. People talk about them being fragile all the time. So I printed these 3D printed connectors to go on, or caps to go on. This thing gets 800 megabytes per second of data across this connector. And if you look, it's got so many pins. It's an array of like 6 by, I don't know, maybe 20. And it's similar to, if you look at modern CPUs, like x86 CPUs, they don't have pins, right? They just have pads. And so that's what this is like, but instead of having pins on one side and pads on the other side, it's pads on both sides. So like that's just one example of the crazy like engineering stuff that they went through on this. And so the V Pro that I bought from Taiwan was actually a dual V Pro. It had 2 of them, and I didn't want to use both of them because I only have a single monitor. And when you have a dual head graphics card in, it goes into like turbo fan mode, and it runs super fast. And so I didn't want that either because it makes a lot of noise. So I ended up pulling off one of the V Pro cards, and that's this one. And so you can see, that's their earlier Mardi Gras architecture, and this is their Odyssey architecture. You can sort of see like the crazy heat pipes and like this thing. How much heat must that generate? So there's only 3 fans in the entire system. There's one fan on the crossbow chip, which is at the bottom. There's a fan on the power supply at the back, and there's another fan that sort of blows over the drive cage that's at the back. And so everything has to be passively cooled. And I don't know why they did it, but I like it because the little fans that they put on GPUs, those things always die. And so it's better to just have a single fan than have all these little fans that die all the time. So I finally worked up the courage to rebuild the Octane, and one weekend, a few weeks ago, I pulled it all apart, cleaned everything up, and it wasn't really that dirty, and reassembled it with the Crossbow 1.4 front plane that I got from Mashek. Powered it up with the original ESI graphics. The second Octane that I bought came with ESI graphics, which are basically the same as the SI, but just a little bit faster. They're enhanced. And so put the original graphics in just to make sure. So then disassembled the V Pro, took out one channel, so I only had a single channel, put that baby in, and everything worked. And so it's great. So now I have the machine that's here today. It's a dual 270 megahertz R12K CPUs. It's got the Cherokee extra power supply that I bought on eBay. It's got that Crossbow 1.4 front plane, and it's got the V10 graphics. So it's basically an Octane 2, but in an original Octane case. So, second story. Now on to the third story, the software. So in early 2005, I was living in Russia, working remotely for a research lab in New Jersey, and I was kind of stuck in the apartment and had some time on my hands. I already knew 3D graphics, how 3D rendering engines worked from the one that I built in DOS years before, but I had never written anything with OpenGL, and so I thought it would be a good career move and an interesting technology to pursue, and so I started thinking about what kind of a game I could write to begin to learn how to use OpenGL. I was thinking it would be cool to make something that was an homage to a classic video game. And so one of the most primitive but most interesting games for me has always been Space Invaders. I remember, it's right over there, right, at a very young age, seeing someone play Space Invaders on an Apple II or an early IBM PC when my dad had taken me to visit one of his techie friends. And I always remember that, like, oh, that looks so cool, that looks so much fun, you know? And so I thought, okay, it would be great to make a modern 3D game that was an homage to Space Invaders that also addressed some of what I perceived to be the shortcomings of the original game. I always remembered being frustrated by the fact that you could only shoot a single bullet at a time and that the bullets moved so slowly. So this was how my idea for Invasion 3D was born. So this was in 2005. I envisioned a fast-paced game which had the look and feel of the classic Space Invaders, but where the player had multiple weapon types of varying speed and damage, where the player could unleash absolute alien carnage on the invading hordes when the circumstances called for it. If like they're going to kill your people, you don't want to just like shoot one bullet at a time. You want to shoot all the bullets and like destroy them all. And so over the next few months, I cranked this thing out, made this game supporting both Windows and Linux, and released the binaries as freeware. I remember getting a few emails during the first year or so after I released the game, and while obviously it wasn't a huge hit, it did create some addicts. I got a few emails from people who had crushed my highest scores that I had, made while developing the game, and they had expressed, how much fun they'd had playing it. So in 2011, I released the source code and gave it a proper open source license, and not much has happened since then. So this formed the basis for my vision of what I wanted to show today. I thought if I could take my Invasion 3D game, make it build and run under IRIX, interface the ELSA 3D glasses with the SGI Octane, and make it fast enough to do stereo rendering at 100 frames per second, that would be awesome. And that's what we have here today. And it's not just straight Space Invaders. This game has all kinds of crazy stuff like kamikaze aliens, Moonanites, mystery spaceships, and even an ending. And so there's 20 levels. If you beat all 20 levels, there is actually an ending at the end of the game, which I have not seen in 20 years. So yeah, that's another thing about stereo visualization is since the frame rate is cut in half, since each frame only goes to one eye or the other, people are very sensitive to low frame rates, right? If you have your monitor set to a typical 60 hertz frame rate, each eye is only getting 30 hertz, and it can cause eye strain, fatigue, and nausea. And so you want it to be as fast as possible. And so actually with the Octane, with all the SGI machines, the video output is totally customizable. There's actually a compiler, and you can write a description of exactly what timing and signal levels you want and compile it into this object, which then becomes a mode, and you can set that mode. So you can, I mean, people create modes to work with 1920 by 1200, like LCD monitors, all kinds of stuff. And so I made a video mode that's 100 hertz in stereo. So the impact graphics cards, that's another thing. That's why this was such a perfect fit, because all of these things have built-in connectors for 3D goggles on the cards. The impact cards all have a little DB9 stereo sync port, and the vPro cards have a 3-pin mini DIN port, which is exactly the same connector. We released the source code under a non-commercial license in 1998, and some open source people took it and continued developing it. They pretty much kept it true to the original, but they ported it to use OpenGL instead of their software rendering, and they sort of modernized the code base. So several years ago, one of the developers who hangs out on the SGI Discord server had forked off a version of this open source Doom or Descent project and ported it to run under iRigs. And so after hearing about this, I asked him for a copy, and he sent me a binary build of the game, which I was really surprised, but it actually works just as it is on this machine and runs like super awesome. It's like 30 frames per second, 1024 by 768, and it's OpenGL rendered, right? It's rendered by the hardware. And so, and the other funny thing is that the developer who did this work doesn't even have an SGI machine with texture RAM, right? So he's never seen it run at faster than like 2 seconds per frame. And so I showed him a video of it running on my Octane, and he was blown away. He's like, "Oh man, that looks great!" And so we can play that. We can play. Here we go. It's going to be in 3D mode. So this is 3D mode. I can hit Control S and switch it into 2D mode. So it's controlled by keys. We can hit F3. It has support for joysticks, but I haven't even figured out how to attach a joystick to the Octane. And so it's arrows, space is to fire, left alt is for shield, and P is for pause. Then there's 4 weapons, 1, 2, 3, 4. And so just if anybody does want to play and try to get through all 20 levels, the strategy is you stick with just the first. It's too loud. So yeah, there's my shield. So the strategy is you stick with this slow, crappy weapon which has no ammo limit for at least the first 5 to 6 levels, if not like 10 levels. And then once because you get bonuses for doing things, like you get 25 bullets. Okay, so there's my bullets. So the bullets are much faster. And so there's all these different bonuses that you can get. If you get 90% hit rate, you'll get an extra guy. And so you want to get 90% as often as you can. And you build up your stockpile of bullets. And, oh yeah, 4 is a cannon, so this is a cannon. Right? And stockpile all of your ammo, because you're going to need it in those last like 5 to 6 levels. It just gets wicked hard, and you just have to unleash everything you've got, or else, yeah, you're not going to make it. So that's the strategy. There it is.
Yay! Thank you. Questions, anybody? How long did you take to develop this game again, Richard?
It was early 2005.
And it took you
4 or 5 months.
Oh, 4 or 5 months.
Yeah.
Oh, okay.
Yep.
I don't know if you've heard this story about SGI and how they got started. I heard there were a couple of guys who developed this really cool graphics card. They went to IBM and they said, 3D graphics is the latest thing. You got to allow us to sell this for the IBM PC. And they said, no, we're not interested. So then they went and built a whole computer around it, which is how SGI was born.
Okay.
Ironically, a couple of SGI engineers towards the end of SGI said, look, there all these PC voodoo graphics and stuff is coming up. We should release an SGI graphics card for the PC if we want to go with the flow. And they said, no, we're selling, $100,000 systems for the military. We're too good. Nobody can beat us.
Yep.
So those folks left SGI and formed NVIDIA.
Oh, really? Yeah. And beat them.
Yeah,
Yep.
obviously. So I just wanted to know if that's. If
I haven't heard that, but
corroboration
it
to
may
that.
very well be true.
Yeah.
They were making. They probably started in the 80s, I would think, and they have a sort of a similar trajectory to Commodore, where SGI was reliant on MIPS for their RISC processors. They bought MIPS, right, and they brought MIPS in-house, and they started developing MIPS, and then just like Commodore owned MOS.
Yep.
And since you're into stereographics, I'm into stereographics too, by the way. I worked at JPL for over 30 years. We had a lot of SGIs. I worked on the Mars program, so we were driving the rover using the stereo goggles
wow.
and
Yep.
SGIs. We had the infinite reality systems and all that
Okay,
stuff.
yeah, that's the Onyx.
Yeah, the Onyx.
Yep.
And,
Onyx
we had
2.
the Indigos as well, but all
Yeah.
the way to the infinite reality, infinite reality 2 and so
Oh,
on.
that's cool.
So there was a brief period where consumer electronics released these cool stereo TVs like LG.
Yep.
They have the passive,
Yeah.
odd lines, even lines,
Yep.
polarized
Panasonic.
one way.
Yep.
Yeah.
Is there any technology you know of that can convert a normal like 4K or 8K TV to a passive polarized system, like some sort of a sticker you can put on it? Because that's all it takes. Just
Yeah,
odd
you
lines
have
and
to
even lines.
register it perfectly
That's
to
the
align
only
it
itch.
pixel
Exactly.
accurate.
Exactly. If you could do that, then that's all
Yeah.
it takes.
Yeah, they had, a lot of so 3D became big in the cinema industry also. Like, if you look at 3D, in the 50s, it had this, curve where it got super popular and then died. And then I think in the 80s, and then in, 2004, or maybe it was later than that, 2008, the same thing happened. And so they were using infrared, they were active shutter glasses, most of the TVs, and they would run at 100 or 120 hertz, and then they would have an IR emitter. And then eventually they went to RF emitters, which these glasses are not that great because they're not completely opaque, right? They're 90-something%, and so, because they're old. And so I bought newer glasses that were made for TVs, but they are RF, and so there was only one company that I could find that was still selling the RF emitter, and it uses the same VESA port, right? So I could plug it in, but it's coming from Germany, and I ordered it a week and a half ago, and it's been in Chatsworth for 2 days. Freaking
You need shutter glasses. Let's talk.
Yeah.
I run a museum in LA called 3D Space, and I have an archive.
Oh, okay.
Everything's
Every shutter
There you
glass.
go. I can hook you up.
So I have new ones that I think are really, really good. They're 8,000 to 1 contrast ratio, so they should be nice and dark, but they're sitting in the post office.
Oh.
Maybe they'll come today and I can bring them tomorrow. I don't know. It's a possibility. But these do work, and the 3D works with this, and you can adjust it too, right? So Control S turns it off and on. You can adjust it to make it pop out more into the monitor. if you want.
What language did you use to program this?
C++. Yeah. All the source code is up on GitHub. And all these guys are programmatically, because I'm not an artist, I love art and I wish I could draw, but I'm super bad at drawing. And so all of these things, it's all just, okay, I want a sphere that's sort of compressed, and so I'm going to have, sine and cosine, and everything's totally parameterized. And I've just got all these constants in there that tell, how far up is this little eye, how wide is the eye, and how tall is the eye. It's all in source code. Yeah.
So you didn't use like a sprite editor?
I did not.
All
There's no sprites. It's all 3D objects, right? And everything is just numbers. It's just a bunch of numbers. Like, you've got an acceleration. It's going to be, I don't know, 50 pixels per second, whatever. And I just play test, and okay, that needs to be 10% faster or 20% slower. So yeah, it's just like developing a game is just like this iterative process of, okay, well this needs to be a little bit harder, or this needs to be a little bit easier, or I want to add this extra fun little capability here. And so there's a bunch of like crazy stuff that I put in this game. I was really into this crazy Aqua Teen Hunger Force cartoon that was on Comedy Central. And so the Moonanites are in this game. Aqua Teen Hunger Force.
Yeah. I figured when you said that, I'm like,
It's awesome.
Do you think the stereoscopic stuff goes in waves when they finally realize
It does, yeah.
Because if they're like, this makes me feel ill,
Yes.
and then people love it, and then
Right.
they hate it, and then they love it again, and then
Yep.
they hate it.
It just seems like such a cool idea, but then you run in, there's a fundamental problem with it that will, see, not everybody is affected the same way, right? And I'm actually partially stereo blind, and so my brain doesn't merge the two images together, and so most of the time I don't get a very good effect from it. But some people are very, very sensitive, and they can determine placement with disparity super, super accurate, and then other people like me can't see it at all. And similarly, like some people get really sick from it, and others it doesn't bother them. But the thing is, okay, your brain is determining based on disparity that an object is at a certain z depth, right? It's back here, it's here, but you're always focusing on the plane of the monitor. And so that is a disconnect, which is what causes that discomfort, because your brain knows that you're focusing here, you should be seeing the thing here, but because of disparity, it's here. Yeah. And so it's kind of a fundamental thing that you can't really fix. Maybe with a head-mounted display, it doesn't have that problem quite as badly, because you can just focus to infinity or something.
Thank you, Richard.
All right.
Thank you very much.
Thank you, ladies and gentlemen.